negative side. This is our bending moment diagram. So now I wish it is very easy for us to plot the variation of shear force and the variation of bending moment along the length of the beam when the beam is subjected with the UVL. See over here on this PPT the diagram that we achieve over here. 0, 1.67 and 13.33 joined by cubic parabolic nature. So now we have seen the cantilever beam with the three different kinds of loading: point load, UDL and uniformly varying load. Let us we go with the next problem. See the problem. Think what is this problem is different than the previous problem. This is the problem with the beam of cantilever beam subjected to the UVL, but the UVL which is of trapezoidal nature is acting in this region of 1 meter, and on this region of 1 meter not a single load is acting. What is the behavior of shear force? What is the behavior of bending moment? That we have to study over here. Go for the step number 1, that is determination of support reaction, as it is not necessary but it is our tradition to find out support reaction first. Let us we go for support reaction first. Using sigma h is equal to 0, RAH we obtain as it is equal to 0 because not a single force which is of horizontal nature is acting along the length of the beam. Taking sigma v is equal to 0 and assuming RAV which is acting upward, so plus RAV. Now this acting load is which is of downward, so minus sign area of trapezoidal, that is 20 plus 10 by 2 into the length 1, we achieve RAV which is of 15 kilonewton. If you do not know this formula, area of trapezoidal, then you can divide this trapezoidal into two parts, rectangle and second is triangle, or you may divide into two different triangles also. Any one option, or out of three, any one option is acceptable. Answers remains unchanged. RAV which is equal to 15 kilonewton, and this positive sign indicated that our assumed direction of upward nature is right. Next, sigma m at A is equal to 0 means summation of all the moments of the forces acting over here is 0. Assuming MA which is of anti-clockwise nature, so minus MA, minus means we are assuming over here as it is anti-clockwise. Now this load creates a moment on this side that is of clockwise nature, so it is plus, divided into two parts. First which is of this UDL, that is of the rectangular part, 10 into 1 into this 1 plus 1 by 2, because this rectangle is nothing but of UDL acting at the CG, that is the center, that is the half of the loading area, that is the center half, 1 into 1 half, plus this triangular load, half into 1 into 10, that is the area of triangle, into distance 1 plus 1/3 of 1, that is 1/3, which is equated with 0. Simplifying this equation, we got MA is equal to 21.67 kilonewton into meter. Positive sign. Positive sign indicated that our assumed direction of anti-clockwise nature is right. So MA which is of anti-clockwise nature and the magnitude is of 21.67. Let us we go for plotting of shear force diagram and bending moment diagram on the tabletop. Now the given beam, which is of cantilever, specifically it is of UVL, this is 20, 10. We know these reactions are, and this RAV, which is of 15 kN. As per our procedure, at the important points start with the dotted line. This is baseline, all the positive values which is above baseline, and all the negative values are of below baseline. Now let us use the fundamentals. At B point, this is A and this is C point, force is acting of UVL nature. So not a single force is acting at B, because this is a UVL per meter run is there. Then in this case the value of shear force is 0. The value of shear force at C is nothing but the total load acting on the CB region, that is of 20 plus 10 by 2 into 1, that is of 30 by 2 into 1, that is of 15. If we take a section over here, section right downward treated as positive, so plus 15. This is joined by using the fundamentals. Parabola. This is of parabola. Now between C and A there is not a single load is acting, means 15 remains constant, horizontal straight line, and VHU RAV plus. This is my shear force diagram. It's very easy to plot. You may take a section over here, section XX. You can find out the shear force at section XX, and you can got an ordinate at the center way. Answers remains unchanged. So why we are not using the fundamentals? Let us use the fundamentals and then plot it out. Next, variation of bending moment diagram. The value is 0 over here. Now the value at C, means we are taking a section over here, right now over here. Total load is acting, and our intention is to find out the bending moment, algebraic sum of the moment of the forces at this section. So if we will divide into the two parts, rectangle and the triangle, then in that case bending moment at C, because of this rectangle part, my rectangle part is this one, it is nothing but UDL 10 into 1 into, this is total load. Intention is to find out the variation at C, half. Nature, section right clockwise, section right clockwise, treated as negative as this is of hogging nature, minus sign, and we got minus sign. Next, this top part, that is of UVL, so minus sign half into this remaining part. Now what is this remaining part? 20 minus 10 that is once again 10. So half into 10 into 1 into 1/3, because this is acting over here at this point. This distance is 1/3 of 1, and by simplifying this we achieve as minus 6.67. So we achieve this ordinate is of 6.67. Now next, what is the value of bending moment at A? Before we proceed further, just visualize the given load is of UVL. The variation of bending moment along that span, the span which is subjected to the UVL, which is of cubic parabolic nature, so which is of like this, minus A. Now bending moment at A, our intention is to find out bending moment at A. So bending moment at A is equal to, as we divide into two parts, minus 10 into 1 into 1 plus half, 1 plus half, minus half into 10 into 1 bracket 1 plus 1/3 of 1. And if we simplify this one, we achieve the same as 21.67 minus sign 21.67. How to join this point to this point, means what is the variation along this? Definitely it is of inclined straight line, because there is no load is acting between these 2 points. This is my bending moment diagram. So now fundamentally it is clear how to find out the shear force and bending moment diagram when it is subjected to UVL. See this diagram, shear force diagram, and this is the bending moment diagram. Now let us go with the next problem, and the problem which is of the last problem for a cantilever beam, that is of combination of all the loads UVL, UDL and concentrated moment acting at this point. Interesting combination is there. For 1 meter, excuse me, for 1 meter which is of UVL, for next 1 meter it is UDL and then concentrated moment. As usual, step number 1 is to find out the support reactions. This figure shows the conversion of UDL in terms of equivalent point load and conversion of this UVL in terms of equivalent point load. As this is the 10 kilonewton per meter UDL is acting, so 10 into 1 is the load acting at the CG, while this UVL is acting of the magnitude of 25 kilonewton per meter, so the load is of half into 25 into 1. The question is about where it is acting. This UVL is acting from here at this point, it is acting of 2/3 of base, 2/3 of 1, while this is acting from this is 1 meter plus half of 1, that is of 1.5 meter. Now let us go over here. Sigma h is equal to 0, RH is 0. The reason behind is that there is no any kind of external horizontal forces acting. Sigma v is equal to 0, assuming RAV as upward, RAV minus total downward load, that is of half into 25 into 1 minus 10 into 1 is equated with 0, and we achieve RAV as of 22.5 kilonewton plus sign means our assumed upward direction of RAV is right. Sigma MA is equal to 0. Summation of all the moments of the forces at A point is 0, assuming the nature of MA is of anti-clockwise, so minus MA plus, the reason behind plus is that this load is acting and the moment because of the load of UVL is clockwise natures. So plus half into 25 into 1 into 2/3 into 1, see the previous figure. Half into 25 into 1 into 2/3 of 1, and another plus 10 into 1 into 1.5 plus 20, because this concentrated moment is acting. There is no weightage of this 20 to find out the reaction RAV, but this 20 it will take part to find out MA, this MA that is assuming of anticlockwise nature, and we found out MA is of 43.33 kilonewton into meter. Positive sign means our assumed direction is right. Please bear, this is not negative sign, this is plus sign is there, as this creates a clockwise nature. Next, bending moment diagram and shear force diagram variation is there. Let us plot over here the tabletop. The first, which is of this UVL, next this UDL 20, this is of 10, this is of 25. Now variation of shear force diagram that our intention is to plot. This 20 do not have any kind of weightage for shear force, so 0 over here. Length is of 1, so 10 into 1 10, and joining this 2 by